Welcome, future mechanical, mechatronic, and civil engineers. I am so incredibly pumped to guide you through this explainer today. We are looking at your absolute ultimate blueprint for conquering the DEX1084 Engineering Statics course at UCSI University. Whether you're aiming to design the next generation of skyscrapers or maybe some cutting-edge mechanical tech, well, everything starts right here. Today, we're taking the actual syllabus and breaking it down so you know exactly what to expect. We'll be talking about how to visualize complex structures in 3D views, how to mentally animate those unseen forces, and most importantly, how to actually ace this class.
Just like a massive construction project, we're going to build your understanding step by step. Our agenda today covers Welcome to Engineering Statics, Foundation, Forces and Vectors, Core, Equilibrium and Moments, Reality, Friction and Forces, Masterclass, Structural Analysis, and finally, acing your assessments.
All right, let's jump right into Section 1. Welcome to Engineering Statics, setting the groundwork.
So let's kick things off by defining exactly what this crucial core course is all about. Statics is literally the bedrock for your entire engineering future. Now, notice that key phrase, stationary bodies. Unlike dynamics, where things are moving all over the place, statics is all about ensuring things stay exactly where you put them, even under the heavy action of various forces. You'll be using the textbook Essential Engineering Statics, Strategies for Problem Solving, to basically train your brain to look at a stationary bridge or a machine part and clearly see the invisible 3D forces acting upon it.
Moving on to Section 2, Foundation, Forces and Vectors. Look, before we can build a bridge or map out a really complex 3D truss, we need our foundational materials, right? Your journey begins with 3 fundamental steps. First, you have to lock down your units of measurement. Seriously, one wrong unit can literally bring a virtual building down. Next, you need to establish a strict procedure for analysis. Statics isn't about guessing. It's a rigorous, repeatable process. And finally, ensure numerical accuracy. You're going to be crunching a whole lot of numbers before you tackle any really complex structural modeling. Once you have those basics down, you'll start mastering the actual language of forces. You'll move from basic scalars up to advanced vector operations. And honestly, this brilliantly illustrates where your ability to visualize comes in. You won't just be working on flat paper, you'll be resolving 2 and 3 force systems. You'll need to generate mental 3D views and multi-angle perspectives to determine forces and moments in both 2 and 3D problems. It's kind of like turning a complex object around in your hands, but you're doing it entirely with math. Okay, pop quiz time. Let's do a quick knowledge check based on what we literally just covered. What specific mathematical tool will you be using to determine forces and moments in both 2D and 3D space? Think about those 3-dimensional visualizations we just talked about. If you said the Cartesian vector, you are absolutely right. This ties directly to your course learning outcome 1. Cartesian vectors are basically the magical mathematical keys that allow you to unlock and solve 3-dimensional force systems. Up next is Section 3, Core, Equilibrium and Moments. With our foundation successfully poured, we move into the structural core, which is really just making sure things don't fall down or spin out of control. You're going to learn how to apply equations of equilibrium in both 2D and 3D analysis. You'll be calculating moments, which is basically just the tendency of a force to rotate an object about an axis. Imagine a wrench turning a bolt? Yeah, that's a moment. You'll look at moments of a couple and the reduction of complex forces into simpler distributed loads. This is where your spatial awareness and 3D viewing skills will truly be put to the test to keep rigid bodies perfectly balanced. Time for another quick quiz. Before you can even write out a single equation of equilibrium, there is a visual tool you absolutely have to master. What diagram is critical for visually analyzing the equilibrium of rigid bodies? It's the free body diagram, or FBD. Honestly, this is arguably the single most important skill you will learn in this entire course. It isolates an object in space and visually maps out every single force vector acting on it. Without a perfect free body diagram, your structural equations are going to fail every single time. That brings us to Section 4, Reality, Friction and Forces. So, perfect theoretical models are great, but we don't engineer in a vacuum. This section challenges you to step into the real world. You're going to calculate the center of gravity and mass for complex 3D composite bodies, meaning asymmetrical, weird shapes. You'll also dive deep into the concept of friction, look at wedges, calculate centroids, and find the moments of inertia, which essentially tells you exactly how hard it is to change an object's rotation. Let's test your syllabus knowledge again with quiz number 3. Friction comes in several forms in engineering, like fluid friction or skin friction. But based on this specific statics syllabus, what specific type of friction will you be analyzing? You will be analyzing dry friction. This maps perfectly to course learning outcome 4. You'll be working heavily with the coefficient of dry friction to analyze stationary bodies that are right on the absolute verge of slipping.
Now for Section 5, Masterclass, Structural Analysis.
We have reached the absolute capstone of your blueprint. This is where you put on your hard hat and look at massive, real-world frameworks. To analyze simple 2D and complex 3D trusses, think of the skeletal frameworks of bridges or cranes, you will master 2 vital techniques. The method of joints analyzes the structure pin by pin, while the method of sections literally cuts the 3D structure in half mathematically so you can find internal forces super quickly. You'll even learn how to spot zero-force members, which are wild because they hold absolutely no load, but they are essential for the structure's stability.
Here is your final knowledge check for this explainer. When you are sweating over these complex 3D trusses and using the method of joints or the method of sections, what is the ultimate end goal here? What are you actually trying to solve?
The answer is solving all reaction forces of the truss. This hits course learning outcome 3, and it really completes your theoretical toolkit. You want to know exactly how much load every single beam in that structure is carrying. Finally, Section 6, acing your assessments. Knowing the theory is only half the battle, right? The other half is knowing exactly how you'll be graded. So the crucial point here is how you manage your time. Looking at the student learning time, expect to dedicate the bulk of your effort, a whopping 24 hours total, just to the equilibrium of rigid bodies. That is the heavyweight champion of this course. Force vectors follow closely behind at 18 hours, and moments take up 15. Make sure you allocate your personal study time accordingly. And here is exactly how your final grade shakes out. It is heavily weighted toward your exams. The final examination is a massive 50% of your grade. You also have 2 written continuous assessments, Test 1 and Test 2 at 15% each. Plus, you'll be hitting the lab for a 10% lab report and a 10% practical assessment. That lab time is where you'll perform physical experiments on stationary bodies to actually prove the math you've been doing in class. But wait, do not overlook this absolutely crucial role hidden in the syllabus. To pass this course, yes, you must achieve a 50% overall mark, but you also must score a minimum of 40% specifically in your continuous assessments. That means you can't just bomb the midterms and lab reports and hope to save yourself entirely with the final exam. Every single test, every single lab, and every single free body diagram counts. Well, you now have the full blueprint for DEX1084 Engineering Statics. The forces are mapped out and the equations are set. So, future engineers, the only question left to ask is, are your blueprints ready?